So for those who don't know me, I'm Hakan Nohre. I'm a TSA in EMER. And I'm going to talk a little bit about a use case here for SecureX, which is rapid threat containment or rapid threat containment in the cloud or rapid threat containment as a service, all implemented in SecureX. And I work with a colleague here, with Christopher van der Made, and he and me have been doing lots of projects together with regards to programmability. Instead of this dynamic duo, I think maybe this dynamic duo is a bit more appropriate to describe us. Anyway, conclusion here. Instead of going into in detail to this particular use case, I think there is an overall conclusion which is quite important, and that is that SXO or SecureX Orchestrator can be used to write a set of customized for your customer, tightly integrated workflows that can almost resemble an application. And this is easier than you think. And this also allows for easy integration with SecureX threat response. So whatever you do in SXO, you can integrate with SecureX threat response. So the problem statements which we are trying to solve here is really this, that the enemy of automation when it comes to containment in particular is that people are very afraid of false positives. Yeah, it would be very easy to say that we should quarantine everything as soon as you have something bad happening, but people are afraid of doing that because it will affect the availability of the systems. Another problem that we have noticed we need to try to solve here is defining what is the target that is being attacked. And typically in Cisco products and in other products, we are tracking the target by different attributes. You have the IP address. Unfortunately, the IP address, as reported when an IPS or something discovers an alarm, changes frequently from clients and some services as well. We have MAC addresses, but they are not always easily accessible by your firewall, etc., because they are not layer 2 adjacent. And also we are starting to see now that some systems for privacy reasons are starting to use the dynamic or random MAC addresses. We of course also have the host name that requires maybe some sort of client software installed, such as Ep.4 endpoint that can report the host name. And we have also the username, which may require some endpoint software or something like ICE to find out what is the username of an IP address, for example. So the solution we came up with here really is we are correlating security events from any source to reduce false positives. This is all implemented almost in SecureX. We have a penalty-based point systems with configurable thresholds. We are tracking the penalties to IP addresses, MAC addresses, host names, and usernames. And I personally think that the username is the most interesting thing when working with incident response to try to get the correlation with automatically. And if the penalty threshold is exceeded, we are creating a casebook in SecureX. We have as a roadmap item to also create a SecureX incident. We are doing rapid threat containment in ICE, and we are doing rapid threat containment by AMP host isolation. So at a high level, we have a system flow here and the compulsory picture of a cat. We are getting security events from any source, umbrella AMP currently implemented. We are retrieving session information for the IP address that we get from, for example, umbrella. And we are getting that from ICE or Active Directory, actually. And in order to get onto the on-prem devices where we still not have an SSE connection, we are using a little middleware here, which runs as a Docker container. So it's very easy to install. After we have session information, including the username, we are using a database where we update the penalty points. And here we are using the built-in SXO tables from the SecureX Orchestrator. It may not be the ideal database for scaling this up or for high performance, but it's simple to use, and we don't have to pay anything like AWS database services. After we updated the penalty points, if the penalty points have been exceeded, that is, a user, for example, has accumulated a high number of penalty points, we will contain and isolate using AMP for endpoints and ICE. And ICE then again via the RTC middleware. We will also create a casebook and in the future an incident in threat response. So this is the RTC middleware to make it absolutely clear what it does. So SecureX RTC, which is my orchestrator, has a REST API to this middleware, which runs in my lab, or I will soon move it to AWS. It's very easy to install since it's a Docker container. It acts as a broker between SecureX and the internal on-prem devices, ICE and Active Directory. It has a REST API with essentially two important calls: RTC get user by IP and apply an ANC policy. And after that, the casebook should be automatically created, blah, blah, blah. And here we see we will have casebooks for IP addresses, MAC addresses, usernames, and host names. And to see a little bit how that looks in the my SecureX here, if I go to casebook here, I see that we have just created these casebooks for MAC address, host names, username, and this is what we need the ICE for right now. So we see here that this username called Garfield has two observables, which is a domain name and a SHA-256. And of course, we can use this to launch it in investigate into threat response if we want to. Going back here to the actual design at a high level in SXO, we see here that we can have many workflows tied together in an application, and everything starts with capital RTC here is like working together. And this is exactly the same thing that why you would create a function in a normal programming language. So if you look at, for example, RTC AMP events here, it retrieves events from Umbrella for the last 1 hour. It essentially makes an API call to Umbrella, and it will get lots of events back, and it will loop through all events, extract, get the username from this ICE middleware and the MAC address from the ICE middleware as well. And then it will call the main function here, which is handle the normalized events. And this function will take as input the observable, like a domain name in this case, and the IP address, the MAC address, and the username and the host name, which we have gotten using ICE, among other things. So this is like the top level. I will show you also the AMP events. If I can find it here. Yeah, here we have AMP events, which looks exactly the same way, really. It just we need to use a different parsing function, of course, when we pass the response from AMP to find out about the events from the last hour. Instead of running it now, because it would take a minute, I will instead go to old runs for this. This is one thing I like with the action orchestrator, that it saves old runs, which you can use for investigation. So this is a real run here, and you can see that it has been running 7 times in these loops, meaning we had 7 events for AMP. And I can also here dig into one specific workflow, which is like a function, and look at this workflow which is getting the username from this AMP event. And you can see here that it is using a target called RTC ICE, which is public IP address in my lab. And it's posting here the IP address, where we want to find out the username. And we have a very simple response coming back here, which is basically dumping the ICE session table that the middleware has gotten because it has a PX grid connection to ICE. And here you can see information such as the username according to ICE of this IP address is Garfield. And we have other information as well in here, such as the MAC address, etc. And there is nothing preventing us to add stuff such as Active Directory groups, which this user is a member of, which could be super important for incident handling. If this is a member of IT admins or domain admins, it could be a much higher penalty that we should apply. I can show you maybe back to parent. This main function, which is the RTC, handle normalized events, which is essentially checking if it's a new event, and then it's using the tables which are included in SXO in order to update the event table and also to update the penalty table for users, for IPs, for host names. And if the threshold is exceeded here, we will do an RTC AMP isolate host, which will isolate the host from AMP. And we will also, if the MAC address penalty is exceeded, we will apply ANC to the ICE to isolate that MAC address on the ICE. And in here, in these functions, if the penalty is exceeded, we are also creating the casebooks. Or if the casebook is already created, we will then go through here and update the casebook with adding observables to the casebook. See here, we had this investigation done. One user, Garfield, which has domain name and SHA-256. And we started to investigate in threat response. And I did that a little bit before to save time. And we can here see the endpoints here. And of course, here we then also have some extra response actions, which is coming from this system, which is the thing starting with RTC. If you disable the automatic quarantining or isolation, you can still apply this then via the GUI by the right click here. We can apply ANC, we can isolate the host, or we can stop isolating the host, or we can clear the ANC from there. Again, I would say that this is just an example of that you can build pretty cool stuff with SecureX without having to write any Python actually, or any low-level programming language. And I think this is also in a way self-documenting, which makes it quite easy to work with for Cisco people, for our partners, and for our customers.